Hello and welcome to the lecture series on 8051 microcontroller. And in the previous lecture, we were talking about timer, and we will see how a timer works here in this diagram. So let's quickly see once again. So this is the oscillator which is producing clock pulses at 12 megahertz. Okay, so it is divided by 12, so we get one pulse after every 12 pulse of the oscillator here. So if we want to use the 8051 in timer mode, so this needs to be connected. Okay, so it will act as a timer. So if we want to use the 8051 microcontroller in counter mode, then this needs to be connected. So this is a switch, basically either it could be connected here or here. So if it is connected here, then T0 and T1, which are the external pins and can be used to take inputs, and the events that occur, which basically are converted into pulses, and they are given to T0 or T1 or both to count the number of events. So coming below, we have got this TR flag, which basically should be 1 when we run the timer. It should be 1. And here this gate, the gate flag of TMOD register. So here you could see the gate flag. So this needs to be 1 if we intend to use it as a timer controlled by hardware, that is the external interrupts, INT0 or INT1. So that then I have to set it to 1. And again, if I'm using any of the external interrupts, INT0 or 1, then here also it needs to be 1. Okay, so this is an OR gate. So if this is 0 and this is 1, then result will be 1 here. So now basically external interrupts will be acknowledged. While if we are making this gate equal to 0, that is, we do not want the external interrupt to work. So the gate should count independently. Then we need to put this gate equal to 0 here, so that will make this 1. And here it doesn't matter, whatever will be the value, we get 1 here. But please remember that this will not work because gate has not been set. So finally I will get here 1 when the TR flag is 1. So counting will start. So this basically diagram show how a timer works in 8051. So let's proceed. Now I was talking about the 4 modes in the timer. So we have mode 0, mode 1, mode 2, and mode 3. So we will look into each of these modes. In mode 0, mode 0 is basically a 13-bit timer. It could be a 13-bit timer or it could be a 13-bit counter, wherein the 8 bits of THX, so the entire 8 bits of THX, and 5 bits of TLX, so the lower 5 bits of TLX, they are used, and the total is 8 plus 5. 5 will give you 13 bits. So the count, maximum count could be 2 to the power, wait. Okay, so this is a 13-bit counter. Okay, sorry. So each time, again, I'm sorry again. I think I should use the pointer here. So I'm using that. Okay, so let's see. So on each count of TLX increment, okay, what happens? So TLX is this. Okay, so whenever a clock pulse come, so it increments this TLX it could be TL0 or it could be TL1. So 5 bits are here. So it will increment it by 1 till it has a value of 1 1 1 1 and 1. So when another pulse comes, then what happens? So this increments this, the higher bit, TH0 or TH1, and this is reset to 0 again. Okay, and then again next pulse comes and it becomes 1 here, then another pulse, and then 1 0 1 1, and so on. And then when again this is completely filled by 1 1 1 1 and 1, and another pulse will come and make it 1 0. I hope so you understand how it works. So let's see now the mode 1. So mode 1 is a normal mode wherein the lower 8 bits, TH0 or TH1, and the higher 8 bits and the lower 8 bits are used. So 8 plus 8, 16 bit are used. So the maximum count that we can go is 2 to the power 16, which is 65536. So the maximum delay that can be produced is this, 65,536 into 12 divided by the frequency. So what happens here? So on each count, the 16-bit timer increments. So it increments from here, 1. When one pulse come, then another pulse come, it becomes 1 0. Then another pulse come, it becomes 1 1. Another pulse come, it becomes 1 0 0, and so on till all the bits are filled by 1, and finally it becomes F F F F H. So this is how we can get the maximum delay. If we are using the number 0, then a maximum delay of this can be produced. We will see how to load a number here to produce a desired delay. So we will see that in a different lecture. For the time being, just remember that this mode 1 can be used to produce this much amount of delay. This is the maximum delay that can be produced from 0 to this value. This much amount of delay can be produced with the help of this mode of the timer. Okay, so now let us look into mode 2 of the timer. So mode 2 is an 8-bit auto reload mode. Okay, so THX bit, which is an 8-bit, it needs to be loaded only. So you don't need to load TLX, only THX needs to be loaded by some desired value which will produce a desired delay. So this number needs to be put in here, and what happens, this number gets copied to TLX, and when clock pulse come, the counting starts, up counting starts, and when it reaches the value FF, it sets, and then another pulse come, then this timer overflow flag is set, it becomes 1, and this is again reloaded with the value that has been initially put into THX. Okay, and this process continues. So we get a 1 after when TLX reaches the value FF every time. Okay, so this mode can be used to generate desired frequency. So this is one of the application of this mode. Okay, so let me just read it out. After the value of TLX overflows from 0FF to 00, then the TFX flag gets set, and again value from the THX gets automatically loaded into the TLX register. So that's what I told you. So let's proceed and see the mode 3 of the timer. So in mode 3, this is a special type of mode wherein we can use 3 timers instead of the conventional 2 timers, although there are 2 timers, but in this mode we can use those 2 and configure them to be used as 3 separate timers. So how is done? Let's see. So timer 0 is used as 2 separate 8-bit timers. TH0 and TL0, they act as independent timers. Okay, so you could see here TL0 and TH0, they are basically acting as independent timers. So for timer to work, we know there should be some overflow flag which should work. So when it is counted up to FF, and then when it overflows, then this flag should be set to indicate that overflow has occurred. So when TL0 overflows, TF0 flag is set, while when TH0 overflows, then TF1 flag is set. So that's the difference. So TF1 is not associated with the T1 timer, but it is associated with TH0 timer. Okay, similarly, so you need to start the timer. You have to use TR1 and TR0, TR0 for TL0 and TR1 for TH0. And again, this TR0 is not used for timer 1. Then what happens to timer 1? So timer 1 can be used in either mode 0, mode 1 or mode 2, but will not generate any interrupt. So timer 1, okay, it is a 16-bit timer. It will work as a 16-bit timer here also, but it will not generate any interrupt. Why it won't generate any interrupt? Because it hasn't got any flag associated with TF1, which was only associated with the timer 1 interrupt, is being used by TH0 timer. Fine. So you may wonder why, how come this timer will work. So basically this timer, when used in this mode, it finds application in serial communication. So in serial communication, so when we'll be looking into the serial communication part of timer, we'll be discussing this mode of timer in detail. So I hope you like this video, and thanks for watching.